Greetings, M Squared here, and we are going to talk about graphing linear inequalities. So, an inequality is less than or equal to, greater than, or greater than or equal to. Sometimes you'll see words like at most or at least, and those represent these. So when we graph them, we're going to graph the line first, but sometimes the line is not included in our solution set. Sometimes it is. So when it's not, there's not an equal to here, which means anything above or below that line, we'll figure that out in a minute, you would shade. So we're not finding just a line here, we're finding a whole region of solutions. And I'll kind of explain that a little bit more as we go along. But you have to know that when it's a less than or a greater than sign, that we have dashed lines because the line is not included. It's the boundary, but it's not included. And then if we have the or equal to, then it is included. If you have less thans, you're going to shade below the line. I always like to test points just to make sure I'm right. But if it's less thans, you're going to shade below the line. Greater thans, you're going to shade above the lines. Okay, so let's remember how to graph a line. When we graph a line in slope-intercept form, that means y is alone. We graph the y-intercept. That's our starting point. So we go down 5. And then we use our slope. Our slope is 2. That's the same as 2 over 1. Remember, the top number tells us to go up or down, and the bottom number tells us to go left or right. So it's 2 over 1. They're both positive, so I go up 2 and right because it's positive. Now, if I was graphing just a line, this is what I would do. And I would say, okay, the only numbers that work are the numbers on this line. And I can grab a number right there. That's 3, 1. And I can see if 3, 1 works. If I put a 3 in there, I get 2 times 3 is 6 minus 5. Yes, that's 1. Any point I pick on that line should work back in if you plug x and y back in. So if we graph that same line as an inequality, remember it's a less than, so it's going to be a dashed line. Now 3, 1 wouldn't work. If I put a 3, 1 in there, is 1 less than 1? No, 1 is not less than 1. So you have to remember that the points, if you're going to check a point, don't check a point on the line if it's like a less than, because it won't work. So we went down 5 and then up 2 over 1. And this time we're going to do a dashed line. And because it's less than, we would shade below the line. But I always like to test a point anyway. Like, for example, I don't think 0, 0 works. So I'm going to test it because I'm pretty sure we shade below the line, right? So if I put a 0, 0, this is my test point. I always check 0, 0 if I can, if it's not going through that origin. Is 0 less than negative 5? No, it is not. And if I test any point over here, it'll be false. If I test any point in its region, it'll be true. So I'll pick another point like this one right here. 6, 0. So if I put a 6 for x, I get 12 minus 5. 12 minus 5 is definitely bigger than 0. 0 is less than 12 minus 5. So we are going to graph a few, and then we're going to do a story problem. So these are the steps in case you are interested. So I like to determine first if it's going to be solid or dashed because I find out that I forget later if I don't do that first and then make a little note. So I'll try to remember to do that. If it's remember we learned how to graph lines in different forms. So if it's in slope-intercept form, I'm going to graph the y-intercept, then use the slope. If it's in point-slope form, I'm going to graph the point first and then use the slope to find points. And if it's just standard form, I find the x and y-intercept and connect them. So just note which one. And if you don't like that, you can just always get it in slope-intercept form, y is alone, and you'll be fine. Okay? And then you can either do the less than, below the line, greater than, above the line, or you can check, and if it's true, we shade that side. So let's start this one. This one is in standard form. So I'm going to find the x-intercept. X equals, when I solve for x, that means I substituted y, right? I'm in for y 0 to find my x-intercept, because anywhere y is 0 is on the x-axis. So I put a 0 in there, which cancels that out. 6 times 0 is 0. So I get 3x equals negative 18, which means x equals negative 6. So this is my x-intercept. So 1, 2, 3, 4, 5, 6. Oh, guess what I forgot to do? It's a solid line. You're supposed to check that first. It's solid. Okay, so now I'm going to find my y-intercept, and when I find my y-intercept, I make x 0. I substitute, so I want to find where the line crosses here. So I put that in, and I get 6y is less than or equal to negative 18. If I divide both sides by 6, I get negative 3. So my y-intercept is negative 3. 1, 2, 3. and it's a solid line. Standard form, I just find those 2 points and I connect the dots. And then it's a less than, so we should shade down here. So let's see. We can pick 0, 0 just to make sure. Is 0 less than negative 18? No, 0 is not less than negative 18. So what happened here is it wasn't in slope-intercept form. So that little rule probably only works when we're in slope-intercept form. Let's try another point. Let's try a point right here, like 0, negative 7. 0 for x, negative 7. Is negative 42 less than it? Yes, it is. So, oh, it is less than. What was I thinking? It was above it. Okay. Hello. There we go. It was a less than, and it was below. So that was standard form. Now slope-intercept form. Here we go. 1, 2, 3, 4, 5, 6, 7. That's my y-intercept. My slope is up 1 over 2. And is it solid or dashed? It is dashed because it's a less than. So we are going to dash it. And since, oh, I'm sorry, it was greater than, but it doesn't have an equal sign. That's why it's dashed. Okay, greater than means we shade above the line. So let's check it. Does 0, 0 work? Is 0 bigger than negative 7? Yes, it is. So we shade on that side. Alrighty, let's try another one. This is in point slope form. So remember, our point is negative 5, 1. It's always the opposite of what you see. So the first thing we do then is graph that. 1, 2, 3, 4, 5, and then 1. So negative 5, 1. It's a solid line. Our slope is 2. Remember, in point slope form, this is your slope, and the opposite of what you see in those guys, this is the x-coordinate and the y-coordinate. I mean, the x and the y are the opposite of what you see there. So now we use our slope, up 2 over 1, up 2 over 1, and it's a solid line, so we graph it. And then I always like to test, but it says greater than, so I'm assuming it's this way. So let's test 0, 0. If it was 0, 0 that I entered in, I would get negative 1 is bigger than 10. It's not. That's why we shade above. Okay, remember, a line that doesn't have a y is a vertical line, so I still get x alone by dividing by 3. I get negative 4. It's a dashed line, so 1, 2, 3, 4. Here's 1 point on the line. Here's another point. X always has to be negative 4, and then I dash it. And this one you don't really have to know above and below because it's fairly obvious what points are less than negative 4. These points over here. Okay, so that's some graphing. And now we're going to talk about our points in testing points. So is 3, 7 in the solution set? You can see what we have a solution set, a whole infinite number of points that go on forever that way. So what we're seeing is 3, 7 in the solution set? So to do that, we just plug in 7 for y. Whoops. It's greater than 7 for y and 3 for x. And then we determine if it's true or not. So this is 6 minus 7. And is 7 bigger than 6 minus 7? Yes, 7 is greater than negative 1. So yes, that one is in the solution set. Negative 2, 0. So we say, is 0 bigger than negative 4 minus 7? Yes, 0 is going to be bigger than negative 4 minus 7. Notice I don't really have to add those. I know that if I have 2 negatives over here, so I'm going left 4, then left 7, I'm still, 0 is still bigger than that. And for this one, I get negative 6. Is it bigger than negative 8 minus 7? Yes, this is going to be negative 15, and that's negative 6, and this is definitely less than that, to the left of that. And now this one, 9 is bigger. Is it bigger than 18 minus 7? Let me make sure I did that right. No, 8 times 2 is 16. Something felt weird there. So 16 minus 7 is 9. No, 9 is not bigger than 9, so that one doesn't work. These ones are kind of a lot easier because all I'm worried about is x. There's no y here, so I don't even care about that. Is 0 greater than 17? No. Is negative 2 greater than 17? No. Is 23? Yes. Is 17? No. Over here, 0. Is 0 less than or equal to 4? Because 0 makes that 0. Yep, that works. Is negative 5 less than or equal to negative 9 plus 4? Well, that's -5 and -5, so it's equal. So yes, that works. Is 2 less than or equal to 21 plus 4? Yep, that works. Is 6 less than or equal to -18 plus 4? Would be -14. And nope, that doesn't work. 6 is not less than -14. And then again with the y, so 16 and 20. So we're just looking at the y. Is 20 less than -3? Nope. Is -5 less than -3? Yes. Is -4 less than -3? Yes. Is 0? No. Okay, so on to a little bitty word problem. You'll see that somebody's trying to sell some t-shirts and some keychains. Their goal is $500. So inequalities can be used to kind of show a range of what, if someone's trying to sell something, a range of what they would need to do to make their goal. So when we look at this, we know that their goal is $500. And we know that they want to meet or exceed that goal. So they want all of this money to be more than that, or at least equal to that. So we're going to call number of t-shirts X, and we're going to call number of keychains Y. And if the number of t-shirts is X, then the money I get from all the t-shirts is 10 times whatever that number is. So I'm going to say 10 times X represents all the money that I will get from selling t-shirts, which means 2 times Y represents all the money I get from selling keychains. So this is the total money I'm going to get for selling X keychains and, X t-shirts and Y keychains. And I need that to be greater than or equal to 500. And then I would graph that. And sorry, I don't have a piece of graph paper here, so I'm just going to kind of show you what that would look like. So we know that we can use our x-intercepts here and a y-intercept because it's in standard form. So my x-intercept is 500 divided by 10. So my x-intercept is 50. And my y-intercept is 250. So I like to find that first because then I know what to count by. So I'm going to count by 50s. Actually, I'm going to count by 50s here because I've got to go. So that's 100, 250. And so I'm going to show you what I'm counting by. So if you don't count by ones, you always want to show what you're counting by because my y-intercept is 250. And then my x-intercept is 50. So I'm going to count by 10s, 20, 30, 40, and 50. And then I'm going to connect them. Now it's an equal to, so it's going to be connected like that. And since it's greater than, I would shade over here. So in order to make that money, I can pick any point in this region, and if I wanted to make exactly $500, I could sell either 50, remember this is t-shirts, because that was the X, right? And this is keychains. You probably want to label that. So I could either sell 250 keychains to make $500, or 50 t-shirts, or anything in between. So if I went over here to 30, I could sell 30 t-shirts, and then I don't know exactly, but if you had it graphed, you could tell more exactly because I just made this up. But this would tell me that anything in here, if I sold 20 t-shirts and 50 keychains, I'm not making my money. So it's just a graphical image of that. So you might have some problems that you need to do like that too. All right, good luck graphing inequalities. M squared signing out.